Okay, here's my idea for a theoretical infinite power source that has no carbon emissions. Zero carbon emissions except for the humans who breathe carbon dioxide. Okay. So here we have position one. You have this piece here that has, there's a weight here at the top. So the object is in equilibrium at this central location, meaning that it's in balance and it won't fall either way. Sorry, these should be positive. This is my bad. These should all be positive, 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 right? So this is an equilibrium at position one right here, right? So what you have is you have this tube and it has all these little rocks or little, like marbles that fall down, through this into, and where they land is, this shouldn't be there. They land is inside of this little, it's like a eight, kind of like an 8-ball, sort of, and they funnel in like this, right, and they roll down through this little tube that is here, like a pinball machine, right? So they roll down into here, and the ball lands right here, which causes the weight imbalance on the left side, which causes this whole thing to rotate down towards the left, because this weight is greater than this, positive negative type magnetic repulsion. So once this object reaches a certain point here, the ball falls out and goes down this tube, which means there's no longer the weight sufficient enough to counter out this positive magnetic repulsion. So what happens is the positive magnetic repulsion rotates this object back upward into the original position. And then another ball falls in and it does it again. So this is like infinite motion led at this 90-degree angle, going left to right, left to right, left to right, like this, for infinity. As long as you have these, you're putting these little balls into this tube, and when it returns to the equilibrium position, another ball falls into the slot, and then it tips again, then the ball falls out, and the magnetic pushes it back up. So you have this infinite motion like this angle, whoop, 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 forever. As long as you have these little weights, it will just go on forever. So all you need is a person. So when they fall out, they land in this little bucket. So the person has to take this bucket and then dump it back into this little container up here. And as long as you have a person that can grab these little balls and dump them back in up here, this thing will go on forever, right? There's no carbon emission. It's purely mechanical. And this rotation will just go, it will just, like this, ding, 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 just like forever. And it's powered by these little balls that create the weight that rotate it down, and the ball falls out, and then it gets pushed back up. And as long as you have these little balls where there's this, this bucket where the balls fall into, and then the person, grabs them and dumps them back in up here. So all you need is one human being to lift and put here, and then you have this infinite power source that doesn't, have carbon emissions. Right, so this is like an electrical generator that's powered by just weight. Right, so the power is, the power is actually coming from the person who's lifting, the little weights and putting them in this container up here. And as long as he continues to do that, the electricity will continue to be generated. And then, you can sell the electricity for money. Because, you can sell the electricity to the power company. So your whole job is you just go bucket after bucket of these little balls and you drop them in up here, and then it generates electricity. So you can have like a 40 IQ. A monkey could earn money doing this just by grabbing a ball, putting it in the top, grabbing a ball, put it at the top, grab a ball, put it in the top, and the electricity just goes. And that you just get dollars, right? So whether this is an efficient, You know, whether the money you're getting from doing this is enough to pay for the food you're eating and things like this, I don't actually know. You know, I don't actually know if this is an efficient design, but in theory, this is like an infinite energy source that only requires a human being, you know, to take the ball and put it back in the top of the chute. Right. And this, in theory, could be done. This could be like it doesn't have to be a ball. You know, it could be like it could be water in a little cup. And then when it tips, the water pours out, and this it's just like a flow of the pressure. You know, there's a flow of water that goes up the pipe into here, and then it flows out through here and goes back into the original container. So it's this flow of water that just continuously goes through and generates this electricity, you know, this rotation like this. Right? So this flow of water could be generated by a stream, you know, by a river, something like this, and all the water has to do is just fill up this little pouch, which upsets the balance between the positive equilibrium of the magnetic and causes this to rotate down. Once it reaches a point here, you know, the water tips out, and then the weight is gone, and it rotates back up to equilibrium from the positive and magnetic association, right? So the water tips out, goes back into the river. So the flow of the river, you know, puts the water into this little cup, causes the thing to tip, the water pours back out into the river, and then the thing returns to equilibrium, and then you know it fills back up with water, and it does it again. And this, in theory, is an infinite energy source that is just created by the flow of the river, right? So if you have you know, what do you call it? You know, if you create a pressure difference, you know, like with the hose where you can get the water to flow, you know, out of the hose, you know, it will suck the water out of the, you know, so if you create a pressure such that you have that same flow going through here and here and here, you could have this theoretical, you know, infinite power source with no carbon emission. Right, so this is something where it's just like a little mechanical device, and I can use this at my house to generate energy. You know, all I have to do is just grab these little marbles, you know, that power the machine. You know, I just have to grab them. Ooh, my goodness. Right, just grab them, and then drop them in here, and then this thing will go cheek, 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 just forever. You know, so I don't know if this is like super efficient. You know, it'd have to be tested. You know, but in theory, this is something that could work in theory. You know, and this could just be water as well. You know, it could just be water filling a cup, creates, you know, weight. This thing turns, the water dumps out, and then it goes back to normal. Well, it fills up with water, turns, water dumps out, goes back to normal. You know, so all you have to do is go to the lake and get a bucket of water, and then you have electricity. You can pour, you know, so it's like an artificial thing where you put the water in this container, and then it causes this, you know, rotation back and forth and back and forth and back and forth, and then this is like a generator. Right? So you have, you know, you have different ways where, you know, you have a mechanical device that is attached to here that follows the rotation. Right, so it follows the rotation, and it creates movement in such a way where, you know, so this is going to go like that and then back like that. So position 2 is like this. So if you have this piece here, it's going to theoretically be going around, you know, like this and then like this. You know, so you can make a mechanical device to where this could power all kinds of different machines. You know, if you look at a You know, so you have this wheel on like a train. And there's this slot. You know, this is like a train thing, right? So the movement of this piece is purely up and down, like this. It stays in this exact line here, right? So position, you know, it goes through these various, you know, positions in, but it's, you know, it's just it stays. So the slot is, you know, I'm looking at. So we have these positions for this wheel. You know, here's position 1 of the wheel. Here's position 2 of the wheel. You know, but the slot is lengthwise like this. So let's put position 2 here. It's still in the center. So it stays in this line of just up and down. So this movement, this rotational movement, could be mapped by like this, where this is the same up and down like that. Right. So let's see here. How can we make this work? How can we make it work? So here, so let's map the movement of, you know, whatever this thing is generating, you know. So it's going like this, and then it's going back up like this. So what can we power? What kind of device can we power with this? You know, it's tough. Let's think. All right, so think of like you have this piece here. It's like I'm holding a Q-tip, and there's a pivot right here. So the path of the Q-tip is like this. It's like a quarter circle, right? A quarter circle Q-tip, path of the Q-tip, like this. So we can erase all parts of the circle, you know, and realistically you could have 2 of these, one on either side, like this. So it tips once to one side and one to the other, which would create a motion that is like this, which may be more useful or not, you know, I don't know, to have that full rotation. Right, so the rotation of this other side, you know, so I'm going to go, it goes the opposite like this. So this is the path this back end is following, is like this. You know, so maybe this is a piston and a pump, you know, like this, and there's a valve that only lets air in. So it goes down like this, and this is pulled down, and then the air goes in, and then here's the thing where the air only comes out. It's only allowed to go out. So it's like a pump, where this, you know, you have an attachment here, and as this rotates upward like this, it pushes this piston up, pushes the air out, and then it drops and it sucks air in. You know, so it could be an air pump. You know, it could be a water pump. right? It could be a water pump that pumps the water from down here back up into here and creates infinite motion, right? Because when this piece drops, this piece follows a similar path. So what I have is I attach like a rod here to here, and what will happen is this rod will be pushed upward, and it will power this air pump. With it allows airflow in here, and then only allows airflow out here. So this airflow is used to pump the water from the bottom back into the top here, right? And attached to this motion is, a coil, is a magnet and a copper coil, and it creates electricity from this rotation that is, this is like a half circle here. So let's make sure we're doing this correctly. Okay, so we want to say half circle here is the same as on this side let's go back to here. So this is a half circle like that. On this side you also have the same half circle up to here. So this forms the full circle. It's just happening on opposite sides. And then it reverses and goes back here. So either side is following this path, where here's the pivot in the middle, and then the device is attached to this end. So it's creating mirrored motion on the other side. And what we have is this piston is attached, and this creates an upward, this movement of upward motion here is used to power the pump on the other side. Right, but this also creates a motion, a circular motion about, a magnet and a coil, which creates electricity. So the mechanical motion pumps the liquid back to the top, and the rotational motion creates an electrical charge from like a magnet and a copper coil. So I don't know if you have to complete the full circle. If I'm only doing a half circle with magnet and copper coil, does it still create electricity? That's the question. Okay, we're not sure. So that would be the question. So if I can create, because again, this here is right here. And sorry, I did this wrong. I did this a little bit incorrectly. I'll do it again. It's still the same motion. It was just done at a different angle, so it's not super clear. So the actual motion would be like this. And on the other side, it would be the opposite motion. It would be like this. So this forms if you draw a line like this, and you draw the plane through from these two locations down through here, and this is the plane, and you slide this piece down in this direction, it forms a full circle. It's just displaced. So one half of the circle is over here, another half is over here. So the full circle is still being formed. So in theory, it still would create the electrical created by the magnet rotating around the copper coil, which creates electrical flow, right? So you could say that this is an electrical generator that is also sustainable because this motion here, this piece. There's an upward on either side here of going this up and down, powering this air pump, and there's maybe like a rotation, and then it powers this air pump, where the air inflow is here, outflow is here of air, which then pushes the water back to the top and powers the machine, right? So maybe this is perfectly efficient, maybe it's not, right? But this is kind of the mechanical engineering type mindset.